Welcome to another Portworx demonstration. Many companies are exploring how to manage virtual machines in a Kubernetes environment, like on Red Hat OpenShift. In today's demo, we'll delve into the critical need for reliable data protection strategies for your virtual machines in Kubernetes. In our demo, you'll see how Portworx Backup integrates with Red Hat OpenShift Virtualization to protect persistent data for both containers and virtual machines. In our lab, we have a sample application called Portworx Barbecue, which consists of a web front end consisting of containers and a MongoDB database for storing barbecue orders running as a virtual machine. Both elements of our application are running on Red Hat OpenShift. We'll start the demo by adding some test data to our demo application by entering a food order for our fictional barbecue restaurant. When we're done ordering, we can see our order history in the web page, which shows the data in our MongoDB database. Now that we have some critical data entered, we can focus on the data protection aspects for this application. From the Portworx Backup 2.7 UI, we can see that we have an OpenShift cluster already registered and ready for use. From this dashboard, administrators can add multiple clusters to seamlessly manage all of their Kubernetes backups and restores from a single UI. When we select our cluster, we can then look at the Applications tab to find our deployed resources. We could use the Namespace tab and filter our namespaces to find our applications. When we find our namespace, we can further filter the list of resources to only the parts that we care to protect. Oftentimes, it's the entire namespace, which is the default, but sometimes we want to limit what's being backed up. In this case, we'll cancel that option and just focus on the VMs tab. Here we can see only the VMs that are deployed on this cluster without worrying about the other objects. Here, we'll select our MongoDB virtual machine to create a backup. In the backup creation window, you can define a name for the backup and what object store or NFS location you'd like to send the backups to. You'll also need to map your storage classes to a CSI snapshot class so you can take a CSI-based snapshot of the volumes, which can then be offloaded to your backup location as well, so that they are protected in case of a total cluster failure. As with most backup solutions, you can either take an ad hoc backup or set them to a schedule so they run every hour, for example. There's also an option for custom rules for your backup. By default, a virtual machine backup will quiesce the file system before taking the snapshot. But you can create your own pre-exec and post-exec rules if you wish to override the defaults. These options are also available for container-based backups as well if you're running a database in a container instead of a virtual machine. So then click Create. In a moment, you see the backup being taken, but to save time, I've sped up the video to show you the Portworx backup dashboards after taking hourly backups on the MongoDB database. From the dashboard, you can view the backup status very quickly and of course can drill into each of the backups to see details about them. Now let's simulate a data failure by navigating to the OpenShift console and finding our MongoDB virtual machine. We'll then delete that virtual machine to simulate a failure. When our database is deleted, we'll check back on our application and we can see it's no longer functioning without its database backend. So now we can begin the process of restoring from a previous copy. We'll select the most recent backup from our dashboard and click Restore. That opens a wizard and allows us to enter a name and which cluster to restore to. Should note that if you have an OpenShift virtualization installed on another cluster, you could restore this VM to another OpenShift cluster, which is a feature often used to migrate workloads between OpenShift installations. Similarly, if you select the custom restore option, you can remap the storage class or namespace, which can be used to transform your application during a restore. Oftentimes, a restore to another cluster requires you to change the storage class that are used with Portworx Backup. This can be managed with a custom restore. Once the restore process has completed, you'll see the status in the Restores tab. You can select the individual restore to see details about the status. From the command line, you can see that we have a virtual machine instance and a PVC that were recently created. From the OpenShift dashboard, you can see that we now have the Mongo VM running again in the Virtual Machines menu. Lastly, if we check our application and refresh the site, we can see that our previous orders are showing up again and our application is working with our database once again. With Portworx Backup, you can protect your critical data running on Kubernetes regardless of whether that is a container with a persistent volume or it's a virtual machine instance running on your Red Hat OpenShift Virtualization cluster. That's it for this demo. We'll see you next time.